Hey, 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 what do you say? Cramer's Rule, Part 2, or second time we're looking at it. And we'll be solving a 3 by 3, so 3 equations. So we'll have an x, y, and z with 3 unknowns. So our answer will be ordered triplets. So we're going to have an x value, a y value, and a z value. So we did this by Gaussian elimination and back substitution, but we're going to use matrices another way and find x, y, and z this way. So see which way you like the best. Alright, here's the example I'll teach. We saw 2 by 2 using Cramer's rule, 2 equations and 2 unknowns. Jot down this example and see if you are shocked and amazed. Okay, so there's the 3 equations and 3 unknowns. So we are wondering where, this is representing 3 space. It leads to something we can understand. So if I take the x and y axis and I throw it down on the floor, so here is my y and here is my x. So it's more like that. And then we add a z-axis that rises up out of the floor and goes down under the floor. So x, y, and z. So we are wondering somewhere in this 3D space, these 3 equations intersect. So maybe the line is coming down like this, and another line is coming like this, and another one's coming like that, and they intersect somewhere. So we're looking for that spot. So just so you know what we're doing, alright, let's skip that. Go right to Cramer's rule. Alright, to find x, we're going to make a fraction using determinants, and the bottom is going to be the coefficient matrix. So I'm going to grab the coefficients -1, 2, and 3. Here are 2, 0, -4, -3, 1, and 4. Can you hear my dishwasher? Sorry. Alright, when we're solving for x, the x values in the determinant will be replaced with the constant 1, 0, 2. And then the y's will grab like normal and -3, 1, -3, 1, 4. Alright, the thing is, I haven't taught you how to find the determinant of a 3 by 3 matrix. So this will show up in the middle of our lesson on Cramer's rule. So what we do, I'll do the bottom one. It will appear in our x denominator and our x, our y, and our z. So we'll go here, we get the most traction. So I'm going to repeat these 2 columns, -1, 2, and 3, 2, 0, -4. And I'm going to make diagonals where I can grab 3. So if I made a diagonal here, I'd only grab 2 and 1. So I want to grab 3, 3, and 3. So along each of these diagonals I multiply. So if there's a 0 in the diagonal, -1 times 0 times 4, it's going to be 0. 2 times 1 times 3 is a +6. 3 times 2 times, -3 times 2 times -4 is a 24 positive. So I'm going to add those and get a 30 in that diagonal. Now I'm going to go this way, wherever I can grab 3, and I'm going to take the opposite sign. So this has 0, the opposite of 0 is 0, because 3 times 0 times minus 3 is 0. Here I grab minus 4 times 1 times minus 1, which would give me a 4, but I'm going to use minus, always the opposite when I go in that direction. 4 times 2 is 16, so I'm going to make it negative. So up here I get a negative 20. Now I combine these by adding them, and 30 and negative 20 gives me a 10. So the determinant for that bottom coefficient matrix is 10. So let's do the same thing for the top. I didn't leave myself much room, so I'm going to go over here. So 1, 0, 2, 2, 0, negative 4, negative 3, 1, 4, and I'm going to repeat the first two columns. And I'm going to go along the diagonals. This one gives me 0. This one, 2 times 1 times 2 gives me 4. And then I'm going to get another 0. Anytime there's a 0 entry, I know when I multiply I'm going to get 0. So along there, 0 plus 4 plus 0 equals 4. Going this way, 0. Minus 4 times 1 is minus 4. I take the opposite sign and another 0. I didn't get that before. I got a 4. Oh, I guess I did. Sorry. So then we add these. 4 and 4 gives me 8. So the coefficient of this was 8 and the coefficient of that was 10. So that gives me a fraction, 8. So the x value is 8 over 10, reduced to 4/5. So going up here into my ordered triplet, x is 4/5. Alright, so let us do y in similar fashion. So I'm going to set up y. I know the coefficient of matrix, the determinant of the matrix on the bottom is always going to be this coefficient matrix. So we already got that as 10. So I'm going to put a 10 here instead of that matrix. Now my y is set up just like my coefficient matrix from up here, except when I get to the y values, I don't use the 2, 0, minus 4. I replace them with the constants. So, alright, I can't keep that all on the screen, but you have it before you. So I'm going to have a negative 1, 2, and 3. On the first, on the last, I'll have negative 3, 1, and 4 unaltered. But remember, when I'm looking for y, the y values are replaced by the constants, which are, what were they? 1, 0, 2. Alright, so this is going to, I'm going to repeat these two columns to get the determinant. 0. 1 times 3, positive 3. Negative 3 times 2 is negative 12. Alright, so 3 and a negative 12 gives me a negative 9 along that diagonal. Going up, 0. The opposite of 2 times 1 times negative 1 would be a positive 2. 4 times 2 times 1 is 8, so I'm going to put a minus 8. And I get a minus 6. Minus 6 and minus 9 will add to give me a minus 15. That goes over a 10 and reduces to minus 3/2. So up we go. Alright, one more. Alright, let's see if you can come up with the z. I'll set it up, see what you can do. So the coefficient matrix has a determinant of 10, and the z matrix, we'll put the constants here instead of the z values, and these will be unaltered. Alright, I'll let you get the determinant of that. Remember to repeat the two columns and go along the diagonals, multiplying. add each diagonal, and then when you go up, the diagonals are the opposite, and you add those. Then you will add those from the bottom, the down diagonals going down to the diagonals going up, and divide it by 10. Alright, so look back how I did x and y and see if you can come up with z. Alright, so now we have used Cramer's rule to find the intersection of three lines in 3D space. So I will be interested to see who gets this right. I'll give you 2 tallies if you get it right. Okay, those will go into homework problems that you can drop. Sweet. Alright, till we meet again, carry on.